Hi, my name is Chris Williams, and today I'm going to be showing you how to use the Parker Automation Controller, or PAC, to control a Lexium MDrive motor. We will be using the Ethernet connection on the PAC to communicate to the motor over Modbus TCP and the PAC I/O modules to control the motor functions. The hardware we will be using includes a PAC, a NEMA 23 frame Lexium MDrive motor, 2 PAC I/O modules for our digital and analog I/O, a 24-volt DC power supply, and an Ethernet switch. Before we can begin configuring our hardware and writing our code, we're going to need to make sure that all of our devices can communicate with each other. To do that, we're going to switch over to our computer and make sure that they all have the proper IP addresses set. To get started, we're going to make sure that our PC, PAC, and motor are all on the same subnet. The default IP address for the PAC is 192.168.10.50. Because of this, we're going to make sure that our PC is set to 192.168.10.75 and the subnet mask is 255.255.255.0. Next, we'll open the PAC configuration tool, putting the address 192.168.10.50:81 in the address bar of Internet Explorer. From here, we can configure all the settings for our PAC, such as security, naming, and network. The last step of our IP address configuration is to use the Lexium MDrive's TCP/IP configuration utility. This utility will allow us to set the IP address of the Lexium MDrive motor. We have included a link to the program in the video description below. Once all of the devices are plugged in and have the correct IP addresses, we can begin configuring the setup in the Parker Automation Manager, or PAM. Once open, click the link for a new project. We're going to name ours Lexium Demo and save it in the default folder. Select the PAC model that you will be using and the type of code you will be using. For this project, we will be using structured text. Next, we have to add devices to our project. Right-click on the PAC at the top of the device tree to the left and select Add Device. The first device that we have to add is our Ethernet adapter. Once the adapter is added, add another device under that. This will be our PAC listed as a Modbus master. Next, add the Lexium motor under the master as a Modbus slave. Once our Modbus devices are added, right-click on the EtherCAT master and scan for devices. Next, click the button to copy the devices to the project. Now that we have all the devices added, we can start configuring the different devices we just set up. The first one we will want to configure is the Modbus slave. The first step here is to set up the TCP settings so we can start communicating. Enter the IP address of your motor and a unit ID of 1. Next, go to the Modbus Slave Channel tab. From here, click Add Channel, select Write Multiple Registers. Type in the address for the slew register and enter a length of 2 with a rising edge trigger. Next, do the same, but for the Move Absolute register. Now that we have our channel set up, we need to map those registers to variables in our project. For this, we need to go to our Project tab, which in ours is called Lexium Control. Start by entering the variables as shown. Once you have all the variables set up, we need to map them to the registers. Go back to the Modbus slave device and to the Modbus TCP slave I/O mapping tab. Map the variable we named Trigger 0 for the first trigger and Motor POS as Register 67. With Register 1 as the second trigger, and motor speed as Register 120. Once the Modbus registers are mapped, we need to map our analog and digital I/O. Go back to the main program, where we will add a few more variables for the digital inputs and outputs, and variables for the analog input and module control. Now that we have our variables set, under the device tree, open up our 2 PAC I/O modules for the digital I/O and analog inputs. Now under the digital I/O tab, go to the EtherCAT I/O mapping page. From here, we will set the speed mode and position mode variables as the first 2 digital outputs, and mode selector, start move, and trigger 0 as the first 3 inputs. Next, under the analog inputs tab, go to the EtherCAT I/O mapping page. Set the analog on variable for the set options channel, the channel 1 enable variable for the channel 1 on, and speed POS input for channel 1. Now that we have all of our hardware set up and variables configured, we'll need to write the code that will take the inputs and send them to the motor. I've already completed my code, and you can find a copy of the code in the video description below. Once you have your code all set in the Automation Manager, we are going to log into the pack to download the code to the controller and make sure that everything works. First, we're going to start out by testing our speed mode. As you can see, as we turn the potentiometer, it adjusts the motor speed accordingly. Next, for position mode, as we adjust the potentiometer and give the command, the motor will move to different positions. Thank you for joining us today, and if you have any questions, be sure to let us know in the comment section below.